The official, ladies and gentlemen, is for you to think back. I want you to think of a certain word. Do not call this word out. I want you to think of a specific word that you learned last year. Don't call it out, even though I know you're gonna know this. It's a 9-letter word that has no real meaning in the real world, but you learned in geometry. And if you have learned about one, or to help you remember one thing, let's check with your neighbor quietly to see if, and the three of you to see if you remember what this 3-letter word is, 9-letter word is. What's 9-letter word? Okay. What's the first letter of this word? Okay, if you know how to count it, I like to hear 1, 2, 3. Okay, would you go ahead and just spell it out? Spell it out somewhere, and just make sure you and your neighbor are familiar with what it means. What is it? S O H O okay. And the meaning is that sine. So from here we have that sine of theta is equal to opposite over hypotenuse. We have cosine of theta is equal to adjacent over hypotenuse. And we have that tangent of theta is equal to opposite over adj. Oh, I like that. Interesting. Are we good? And this only applies to what kind of triangles? Right triangles. So do you all know how to find the hypotenuse? I mean, just identifying the hypotenuse. Thank you. It's always opposite from the right. Some people think it's always a slanted one. Where have you been? Yeah, opposite from the 90 degrees, and the other two sides are called legs, exactly. Right? They have 3 sides, but only 2 legs. And with reference to that angle, right, and there we have a theta, but one of the legs is opposite, the other one is adjacent. So you have to be able to identify these appropriately. So these are the 3 basic trigonometric ratios. You know how many trig ratios there are total, though?
3.
There's 3 basic, but there are 6 of them. There are 6 trigonometric ratios. The next one we're going to talk about is cosecant. Does this sound familiar? Cosecant? Have you heard this before? Do you know the abbreviation for cosecant? It is CSC. How do you know about this? Did you do it last year?
Oh.
And by definition, maybe different teachers probably taught different things. Maybe someone was at, maybe they were all absent. Anyway, cosecant of theta by definition is not opposite over hypotenuse. It is hypotenuse over opposite. The relationship between sine and cosecant is that they are not inverses, not opposites. Definitely not congruent. It starts with R. 3.
Wait, I'm there. There, wait.
Rihanna. Repulsive. Race cursive. At least it's mathematical. No. Oh. When you're dividing fractions instead of dividing by, you multiply by the. Thank you. These are reciprocals of each other, aren't they? They're reciprocals. Does that make sense? The next one we're going to do is not cosecant, but it is secant. the abbreviation for a secant is SEC of theta. So by definition, secant of theta is equal to
Off of
hypotenuse over adjacent. Or if you're Sophia, it's hype over adj. And that's okay too.
Wait, oh yeah.
The last one is cotangent. The abbreviation for cotangent is COT, the abbreviation for cotangent. And by definition, cotangent theta is adjacent over opposite. Now, some students try to make up their own SOHCAHTOA for this. Please don't. Just the reciprocal of the other ones. Yes. Sophie.
Wait, never mind. I don't know how to say it.
Maybe you're a little bit annoyed that sine and cosecant are reciprocal. It seems like sine and secant should be reciprocal. They're just not. So it's something you need to accept. So sine is the reciprocal of cosecant, cosecant is the reciprocal of sine.
We didn't learn this. No, we did not learn.
Easy?
No.
Okay, let's do some problems. That 3 and the 4 look familiar, don't they? 3, 4, 5, yay. Okay, so for the 6 trig functions, I'm gonna do the first one and then you're gonna do the, well, I'll do all 6, but we'll do the first one together because when you do sine, I want you to make sure you're saying sine of theta. We need something there. Sine theta equals, specifically in this case. I'll let you finish this. I'll let you finish this. But I do want you to do this order: sine, cosine, tangent. And then I want you to do cosecant theta. So please do this order.
How do we know that C is 5?
Because A is 3, B is 4. So you can use Pythagorean theorem or 3, 4, 5 is a triple.
Well, that also means the why is that please alphabet and it's just
You say why do we still?
Yeah.
It's the standard thing in math where angles are represented by Greek letters, alpha, beta, theta. Why? Check with your neighbor, make sure they got them all. Did you finish? I'll give you 4.5 more seconds starting now. Okay, no more time. Time's up. Thank you for being our official timer. Would you please show me your answer for a sine of theta? You have your 2 hands. Show me your answer for a sine of theta. So I'm seeing 3 over 5. Okay, let's go to cosecant of theta. Nice. Okay, so you got 5 over 3. I think I could write that as a 3. Okay, show me cosine of theta. I can't say 4 over 5. Would you show me secant of theta? Yay, 5 over 4. Show me tan theta. 3 over 4. And cotangent theta. Interesting. Lucy, you didn't change your hands. You changed the digits on each hand, didn't you? Or did you change the hands? Yeah, you just changed the numbers on each hand. Either way works. I saw motion elsewhere, then I didn't see anything here because it was just like a digit difference. Perfect. That was so much fun. Let's do another one. Woo. Are you ready for this? It says 2. This is 1, 2, 3, triangle.
Nobody's so nice.
That's impossible.
Alright.
Root 2.
Oh, my egg got hole punch, but I don't think.
Oh, thank you. That's right. Bad format.
Oh, no. Yes.
Two, four.
Words that are radical denominator.
You're hoping. It's a weird spot, there's just people who don't get one.
Root two. No. Oh, what a beaver. Sweet. Who's that? Correct. Yeah, that's actually not.
Let's see. Did you finish? I'll call on someone to help with these. Okay, here we go. Mia, can you help me out with this, please? The first three on the left. Okay. Where did that 2 or 2 come from? From what? And you got B by? Nice. I appreciate using the Pythagorean theorem appropriately. And tangent of theta? Do we agree? Any questions about these? Okay. So for the other ones, oh yeah, Jaden.
Why is
Well, how are you supposed to do B? If you know two sides of a right triangle, you get the third one using a particular theorem. Any Pythagorean.
say something like 1 squared plus b squared equals 3 squared?
Yeah, it has to be worked out. Why didn't we have to do that last time? Didn't we have the same kind of thing? Why didn't we have? It's a Pythagorean triple. So if you know two of the sides, you already know the third one automatically. This one is definitely not a triple. When I said this is a 1, 2, 3 triangle, that is a joke. What's wrong with the numbers 1, 2, and 3 for a triangle?
1 and 2. Oh.
Yeah, the sum of any two sides has to be greater than the third side. Good catch, Liv. Would you please show me the cosecant of theta? Yay. Looks like a Cub Scout meeting in here almost. I think, yeah. Oh no, Boy Scouts. Okay. And Girl Scouts do that too. I said Scouts now instead of Boy Scouts. Secant of theta. Mia, could you tell us what you got for secant theta? 3 root 2 over 4. Okay, and let's finish it up. And cotangent of theta? 2 root 2.
Okay, special triangles. I already talked about special triangles.
One thing we need to know about is Pythagorean triples. They make life easier. We already talked about 3, 4, 5 today. I'd like to take a moment to discuss with your neighbor quietly which other one or ones do you remember. And it's the three of you. And take turns going back and forth. I'm calling someone in about 3 seconds, in 5 seconds. Okay. Fiona, what's another one? Do we agree? Thank you very much. 5, 12, 13. Can't call Jake. He's not here. But I can call Jaden. Were you able to come up with another one, Jaden? 6, 8, 10. Well, 6, 8, 10 is true, but that's just like it's kind of 3, 4, 5 double. So it's not a separate triple, it's part of
7 times.
Oh, wow, nice. 7, 24, 25. Okay, did anyone remember any others? Yes, Lucy. Ooh, nice. Anyone remember any others? There is one with a 40. There's a 40, 41. 9. Yeah, yeah, you had that 9 in there. 9, 40, 41. Okay. Any questions? Oh yeah, how many triples are there?
Infinite.
There's infinitely many, so there's several with hundreds. I don't know any others off the top of my head, but they exist. And interestingly enough, these three numbers, when you put them together, they make right angles. There are also Einstein triples, which have perfect 60-degree angles in the triangles with integer triples. There was a sign, I don't know if it was the Einstein, but yeah. Yeah, like the best he could do is triangles, which is pretty good. Yeah. It's a non-fuzzy one, yeah. Anyway, some interesting things about Pythagorean triples, just for parties and such. The last two numbers for most of them are just one apart. And odd. No, I think you're right, the last two, but all right, we got the 4, 5, 12, 13, so 4, 35. I need straight into that. But 40, 41, so one apart. But one other interesting tidbit that I just found out before break that I was so excited about was if you square this first one and compare that with the double of this, think about this, the square of this, the first one, and double the last one.
One of our 49.
Square this one, double this one.
Oh, shoot. There we go.
Right? Perfect party conversation. If you don't want more friends. It doesn't work here, but here, 81 versus 8. Isn't that kind of interesting?
No, it doesn't.
Where we could force it to work here. The fact that these are 2 apart. I could make this 1 apart if I take all these numbers and divide by 2. Wouldn't that work? So I have 4 comma 7, 5, 8, 5. And now does it work?
Yeah.
16 versus 17. So interesting. Don't you think? What's that? One student said, "Hey, you know this?" And I'm like, "I had no idea. How do you know?" He said his dad did. Right? Me too. So if you have math parents, share that with them. I bet they interesting. When I say math parents, that's everybody, all your parents. I'm sure they'd love it. Okay, so those are helpful. And the whole point of this is to save you time, right? So if you see something like this, 815, don't do Pythagorean theorem. You can, but for sure the result will be 17, unless you do something wonky. Of course, you just have to be careful. If you have 3 and 5, don't mindlessly put a 4 there. 3.
So just make sure that that largest number is the hypotenuse. Okay. Other special kind of triangles. Would you please discuss with me?
What other? There are two other kind of special triangles that you need to know about. Yeah, they're right here. Here, there. Okay, so let's draw 45, 45, 90 together. Like something like this. Which leg is the largest in a 45, 45, 90? Which leg is longest? Yeah, they're the same. They're equal. So I like to call this A, which and because it's the first letter of the alphabet and the last letter of your name. I really like that about it. And it's the penultimate letter of my last name. Yeah, yeah. What's that? There is we got Avery here. We got Mia, Fiona. Sorry, Charlotte. Sorry, Lucy. Olivia. Yeah. A's all over the place. Okay, so right now you're just filling the rest of that triangle in terms of A.
And also this one. Fill this in. That is a 30 by the way. You know what I mean by labeling the rest of the triangle in terms of A? Don't do like A, B, C. Like we know that these are the same. Did your partner know what this hypotenuse is? Can you use Pythagorean theorem to do it? We could, but we already know from last year, perhaps, or maybe just right now that's 8 equals 2. In other words, if we know that these legs are 5, then the hypotenuse would be 5 or 2. Please don't use the Pythagorean theorem. Like getting there just takes too long. In this other triangle, A, everything kind of comes from the short leg. From there, we know that the hypotenuse is 2A. We just check to see if you ever know something exactly. So it's asking for all 6 trig values for 45 degrees. So you're gonna write sine of 45 degrees. There's no theta here. For this next example, I'm gonna cross out the 60 because that's just too much information. We'll just do sine for all of this. Trig functions of 30 degrees. And yes, simplify. And yes, rationalize. Oh, also. I'm going to watch it. Okay for that. Make sure the tears are not flowing. Unless they're tears of joy. Are we done? Yeah. This happens to me. I'll call on someone for number 3 in about 12 seconds. Okay, the person who's going to help us has the last letter in the name of A. And I already called Mia. I already called Fiona. I have the last letter. First. Sophia, yes. You got tricked. All of them. Let's go from the top of left down. Oh, you said A root 2 over 2A? You didn't simplify that?
Does anything cancel? Is there a common factor in the top and bottom maybe that we can? Oh, okay, I thought that's what you said. Nice. Oh, just one? Are we okay with these folks? Okay, Sophia, are you okay continuing? Okay, I like that. It's not root 2 over A, it's not that? Okay, good. Okay. Okay. The same for, what did you call that? That one after cosecant? Secant. Oh, okay, I thought I heard sec. Okay. And then cotan 45 degrees, that is 1. Are we good? Any questions? Great job, Sophia.
Who needs more time, for example? 4. He's just doing 30 degrees. Sure. Okay. Live. Bad partners. Sine of 30 degrees. Did you get all of these already? No. Okay, let's see what you got. Sine of 30 degrees. 1/2. Okay. How about cosine 30? Root 3 over what? Over 2? Okay. How about tangent of 30? Well, let's do it. Tangent of 30 is
What over what? So we have A over A root 3. The first thing that happens is say adios to the. I'm probably, and you could rationalize first. I'm gonna just get rid of those. The easy one first. Like, root 3 over 3 is what we get.
That'll work under pressure. Nicely done. Can you tell us the cosecant of 30 degrees? It is 2. Let's go to the tangent. And instead of flipping this final answer, how about we flip this? Will that make sense when we're trying to find the cotangent? So you see that the cotangent of 30 is 3. You didn't get secant of 30 yet, did you? Could someone fill us in secant of 30? 2 over 3 over 3. And if you said 2 over root 3, that is
Correct. It's correct, but it's not rationalized yet, but it is a correct answer. Generally, I want rationalized denominators. Easy. Okay, let's.
You know, the sine of cosine theta equal to 15/17. It's up to you to find the rest of these guys. What? Yeah, recognize no that. All six. All six. Come on. Find it again. We ready? Brady, could you tell us what you did here?
So.
Okay. Okay, so you knew that this is the
Opposite, and this is the. Okay, so you're able to piece information together. Nice. Is that how you guys did it? Would you like to continue?
Yeah, and, yeah.
Cosecant. I guess it's not really necessary. Like, this is kind of mind-numbingly obvious, I hope. Brady, thank you for your help with these. Any questions? Perhaps your question is, can we try another? The answer is yes. And I'm going to change this problem. I'm going to, first of all, instead of 1/2, I'm going to make it a 5/13. And I'm going to take away this whole trig identity thing. Just find the value of cosine theta. Yeah, find just the cosine theta. You can find the rest if you like. Yeah, you can cross that out. I'll tell you about it later. Yeah. It has to do with trigonometry. You're welcome. Check with your neighbor. Okay, who'd like to tell us what they did? Avery.
As five. And I really have to get 5/13 triangle.
Okay. Ooh, nice. Are we good with that, everybody? Right, it's not like it's abstract. These are about triangles, so look at triangle, like Avery did, and then it's hard not to be successful. Well done. Let's try this. Yeah, it's too easy. Let's get to the homework. We can do the homework already. Yeah. Yes. Right now. Thank you for reminding me. Let me close this up. Did you all